So as I promised in 12.5, we had a couple, in fact, the first three properties we had in 12.5. So we're going to quick review them, but I promised you there was going to be more properties, which we are about to see is going to happen. And then we're going to apply those properties. So if x, y, and b are positive real numbers, and just like before, your b can't be 1, but r can be any real number, then these properties are true. So now again, the first three that you've already seen, any base of 1 is always going to be 0, because b to the 0 power equals 1. So if this value is a 1, that's got to be a 0. Remember the one that if these two bases are the same, then the answer is simply the exponent. That's this property. This is the one I said you don't see very often, but if the base is the same as the base, whatever that is, and we practiced this before, then the answer is simply x. Now, 4, 5, and 6 are new properties, and it's really important that you know these. What's going to help you is the fact that you have to remember that logarithms are directly related to exponentials. So you'll notice that these log properties are very similar to the exponential properties that we've had in the past. So look at this first property. If I'm taking the log of two things that are being multiplied together, I add the individual logs. So remember the exponent property. If you are multiplying two monomials, what did you do to the exponents? You added them. See how they're related? If for number 5, I'm taking the log of two things that are being divided, I subtract the individual logs. And finally, number 6, if I'm taking the log of a monomial that's being raised to a power, look what happens. That power comes down in front and gets multiplied by the log. So let's practice those. Right now you're thinking, what? But practicing will help. These are so important for you to know for the rest of the course. So look at this one. It says, write each of these as a single log. Well, look what I have. I have two logs that are being subtracted. So that's this property. So I'm going to go backwards. If the two individual logs are being subtracted, do you see where together that meant that these two values were being divided? So I would rewrite this as the log base 10 of 27 over 3, which of course would be the log base 10 of 9. And that's what they're looking for. They just want you to rewrite it as a single log. Let's look at B. Again, we have two individual logs that are being subtracted, which meant division was happening originally. So we would rewrite this as the log base 3 of x squared plus 5 over x squared plus 1. And that's all you would do. You're done. Ooh, now look at this one. These two individual logs are being added. So that's property number 4. If they're being added individually, it means originally these two values were being multiplied. So this is really the log base 3 of 1/2 times 6, which would be the log base 3 of 1/2 of 6 is 3. So now, let's look at this really quickly. So technically, we have done what we were supposed to do. We wrote it as a single log. But do you happen to remember if I have the log base 3 of 3 to the first, if you use this property right here, these are both 3's, the answer is really just a 1. But again, we don't have to go that far. We wrote it as a single log. We are good to go. But if the directions said simplify, we would have to go that one step further. Okay, we have more. because these are really important. So look at this one. Well, first of all, see how the 2 is in front of the log and the 3 is in front of this log? That is our last property. Those are really exponents. So I'm just going to rewrite it right now as log base 5 of 3 squared plus log base 5 of 2 cubed, which, by the way, is log base 5 of 9 plus log base 5 of 2 cubed is 8. So again, these numbers in front are really exponents, and 3 squared is 9, and 2 cubed is 8. Okay, so now look what I have. I have 2 individual logs that are being added, which meant originally the 2 values were being multiplied. So as a single log, this is going to be log base 5 of 9 times 8, which is the log base 5 of 72. Why don't you turn off or pause the video and try to do E and F on your own, and then come back and see what you got. Make sure you're correct. Okay, so if you're back, the way I would do this one is I see this number in front, so that's going to be an exponent. So this would be the log base 9 of x cubed minus the log base 9 of x plus 1. Now, since these individual logs are being subtracted, it means originally they were being divided. And there's your final answer for that one. Let's look at F. So if I look at F, I'm going to say, okay, these 2 were being added, which meant multiplication to begin with. So it'd be 25 times 3. So that would be the log base 4 of 75 minus the log base 4 of 5. Now, since these are being subtracted, that meant division originally. So this would be the log base 4 of 75 divided by 5, which of course would be the log base 4 of 15, because that's what 75 divided by 5 is. So I like to call that condensing, because what I'm taking is I'm taking a long exponential expression and I'm condensing it to a single log. Now let's go the opposite direction. And let's take these and let's lengthen them into using our properties, using many logs. Okay, so for this one, I see this division. So I would say right now that this is the log base 3 of 3 times 7 minus the log base 3 of 5, because division means you subtract the logs. Now this is right here, the log of 2 things being multiplied. So what does the rule say? It means that you add the individual logs. So that would be the log base 3 of 3 plus the log base 3 of 7 minus the log base 3 of 5. Now this does simplify, but it doesn't say anything about simplifying, so we are done. Okay, let's finally do our last one here. So again, we have 2 things that are being divided, so we're going to start off by subtracting those individual logs. Now I have this x being raised to the power. What does the property says happens to a power? Remember, it goes down in front. So this is going to become 5 times log base 2 of x minus, same thing with this 2. It's going to come down in front, 2 times log base 2 of y. And you are done.